So maxima and minima. It's really talking about peaks and valleys. So example 1 says Tony produces and sells dream catchers. Her monthly profit in dollars is found by P of X equals 60X minus 2X squared, where X is the number of dream catchers she sells. And here's a graph. And part A says evaluate P prime of 10 and explain what this means in context to the problem. So we want to find the derivative and evaluate it at 10. So we need to find P prime. And this is equal to 60 minus 4x. So just using our power rule that we have. And then if we want to find P prime at 10, this is 60 minus 4 times 10, which is equal to 60 minus 40. So we get 20. And remember that our derivative is a slope of a line. So change in y over change in x. So our y values is our dollar and x is the number of dream catchers she sells. So this is dollars per dream catcher. Because we're looking at it's looking at a slope, so change in y over change in x. So a little bit further of what this means in context is Tony's profit is increasing by $20 per dream catcher but that's at x equals 10. So that's if she sells 10 dream catchers. So if she sells 11 dream catchers, she'll be increasing how much she makes to a certain point, and then it starts decreasing. The more dream catchers she makes, the less she's making per dream catcher. Okay. Any questions about this or how I put that sentence together or what anything means? So part B says evaluate P of 15 and explain what this means in context to the problem. So I'm going to let you guys try this. All right, we have enough people to make 2 groups. So go ahead and get in pairs. Feel free to move if you want to move, but get in pairs and discuss this problem. See if you guys got the same thing. See if you come up with the same sentence.
So got that it's $0 per dream catcher. And I just said her profit is increasing by $0 per dream catcher. She sells 15 dream catchers.
Oh, so the profit's
Yeah, so just slightly different wording.
All right, so P of 15. So P prime of 15. What'd you guys get for this? 0. And it is 0 because you get 60 minus 4 times 15, which is 0. So 60 minus 60. And when we get 0, that's really dollars per dream catcher. And if we were to write a sentence, you can pretty much copy the sentence we had before. Tony's profit is increasing by $0 per dream catcher if she sells 15 dream catchers. Whenever I say she sells, I have to be really careful. Okay. So is it really increasing if it's 0? No. So what we could really write is Tony's profit is not changing. When she sells 15 dream catchers. So if we go up to the graph, before when we had 10 dream catchers, we were looking right here, and that was the tangent line we were looking at. At 15, and you can see it has a positive, so she's gaining, the more dream catchers she sells at this point, or if she sells another dream catcher, she's gonna gain more money. Well, here, it flatlines. It's 0. That's at 15. So her profit is not changing. If we go to 20, without even calculating, if we look at a tangent line, we can see that tangent line's negative. So her profit is actually decreasing the more she sells. So since it went from increasing, flatline, decreasing, what we can actually say is Tony has reached a maximum profit since if she sells one more dream catcher, her profit does not change. So at that 16th dream catcher from her 15th, her profit's not going to change. We're really close by. So we've reached a maximum point. Okay. Any questions about this so far? Kind of a little introduction into this. Example 2 says identify the following points. And we have relative maximum, relative minimum, absolute maximum, absolute minimum. So we kind of need to know what are these things. So let's give some definitions and write them off to the side. A relative max sometimes it's called a local max. It occurs at peaks and valleys. So a relative, or actually if it's, we're looking at max, it occurs at peaks. So anything that goes from increasing to decreasing has to kind of have both of those is a local max or a relative max. Relative to the points around it, it is a maximum, is another way I like to think about it. So it occurs at peaks, but something also that's really nice, it occurs when y prime equals 0 or y prime is undefined. I can't finish writing undefined there. So if y prime is 0, so you have a flat line, or y prime is undefined, it could be a relative min or relative max. The relative minimum occurs at valleys, and it also happens when y prime is 0 or y prime is undefined. So it's just like a max, except it's a valley. It goes from decreasing to increasing. Now, if we talk about absolute max or mins, it occurs at the highest point on the graph. So the absolute highest point on the graph, it doesn't have to look like a hill. It doesn't have to look like a valley. It's just absolutely the maximum point or absolutely the lowest point. However, it can also be a relative min or relative max. Those 2 points can be the same, or it can be an endpoint. So how this graph stops on both ends and doesn't keep going to infinity, those are endpoints. So one of those could be our absolute max or an absolute min. All right, knowing those definitions, I'm going to let you guys try finding these. questions? All right, go ahead and pair up in your groups. Take turns kind of describing how you found these to the other. Discuss your thought process.
The first one I got to 6.5. Or 6.55, like actual point. We're going to my relative maximums. My relative minimums, I got 4.3 and 8.1. For my absolute minimum, any maximum, I got 10.14. And for my absolute minimum, I got 8. So I think you're I just did that. So I just don't think that anything's gonna be relative. She didn't say it, she just said that only in the absolute maximum ones that everyone's gonna be one of those, so that's my thought process there. That those would count. Is that right? That emphasis can't be relatives.
That endpoints aren't relatives because they don't have both sides.
Okay.
Because it's relative around that point.
Okay.
Yeah.
That was my guess. Good call. Or at least just that they could. I didn't know.
They're changing. Some textbooks are actually starting to include endpoints and relative, which is really annoying because the definition includes both sides, kind of a limit from both sides.
Let's just on that.
So,
I'll use your garbage yet.
yes.
Thank you.
All right. So let's go through these. Relative minimum. Anywhere, or maximum. Wow. It'd help if I could read. Anywhere that goes from increasing to decreasing. So it needs to have a rise and then a fall, kind of like a roller coaster.
6.5.
Yes. So we have 6 here, 5 up here. So I have 6.5. I'm gonna rewrite that with a smaller marker. So we have 6.5. They need less buttons on these computers. Okay. What do you think the derivative is at 6.5? If I drew a tangent line on there. Any guesses?
Equation?
Nope, just what the slope would be. So what's the slope of that tangent line?
So it looks kind of like a 1/1 or
Why don't we draw it?
2.
If I draw the tangent line, it looks like this.
Oh, I was trying to get at it.
So it's flat. So that means our slope of our tangent line is 0, which means my y prime is equal to 0 here. It's this nice smooth curve.
How do you decide that the tangent line should be going right there and not like angled off of it?
So you kind of just look, the tangent line comes up and just kind of kisses the graph and goes off of it. So if I was to draw it here, oh gosh, it would come and touch off. It might be better if I drew it under, but it's just touching the graph at that one point.
Okay, so that's why you couldn't have that 1/1.
Yeah, and so it's so if we have this, if we were like riding along, I can get this to stay. So we're riding along here. Up here where that maximum is, this is flat.
Okay.
Kind of like where you, if you're into roller coasters, where you'd be kind of staying still before they drop you off the end of it.
Thank you.
Visuals normally help. Okay, relative mins, what'd you guys get?
4, 8,
4, 3, and 8, 1. Everyone agree? Okay. So we get 4, 3, and 8, 1. Well, again, if I'm on my little roller coaster here, and I'm moving down, this is my turning around spot. So this is flatlining again. So here, my derivative, my first derivative, is 0. However, we got a small issue. If I'm looking at 8, 1, if I look at the left of that point, my tangent line is like this. And just as soon as I move over to the other point, it's like this. Yeah, it's so sharp that you're not smoothing out like all the other ones are. So this, your derivative is actually undefined. Which brings us to a slight note. If you ever have a sharp point in your graph, your derivative's going to be undefined. So derivatives are undefined at sharp points. So it's 0 anytime the graph kind of smooths out and levels out, but it's undefined at really sharp points because you're literally going from one position to the next without having that smooth transition. All right, questions about that? Okay, what was the absolute maximum?
10, 14.
10, 13.
My time can be off.
All three were just got different numbers, so I mean.
Okay, so let's do this. Did everybody agree on 10?
Yes.
So we have 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. I'll try not to do that to you on a test. If I do something and you don't think you're counting right, put it in parentheses and I'll accept it. Like, okay, you just miscounted.
So, just in parentheses, I can't count.
No, just put like this in parentheses, circle the point and say that this is what it is, and I'll just assume you miscounted.
Okay.
Okay, so our absolute maximum is 10, 13. The graph kind of ends there. If I was to make a guess, it'd probably be a positive. My y prime would be a positive number, which doesn't really help. So relative mins and maxes, we get this 0 or undefined. When they're endpoints, they could really be positive or negative. So the absolute minimum, what'd you guys get? 8, 1. All right. And again, that's down here at this really sharp point. That's our absolute minimum. Any questions about? Okay. So I want to do a little note because I know a few of you are actually doing the homework. So first I want to say that 8, 1 is both an absolute min and relative min. And how the homework is worded, and it makes me cringe a little bit, but I'm not gonna be this picky on the test. Is that the absolute min of the graph is y equal to 1. So if I ask you, what is the absolute min? Or if the homework asks you, not me. If I ask you, feel free to give me a point. If it just says, what is the absolute min? Give it the y value. If it asks you, fine, I'll scroll that up. For the absolute min value, nope, not value. The absolute min occurs at blank, you would say x equal to 8. So if I ask you where it occurs, it's 8. If I ask you just what is the absolute min or what is the value, it's y equals 1. I typically ask for points, so I want both the x and y value. It's probably the easier way to go about it anyways. Okay, any questions? Everyone have this all written down? Okay. So example 3. We have, suppose that f of x equals x cubed minus 3x squared plus 9. Find the relative maximum and minimum points. Well, we can kind of see where one of them is. The other one, we know it occurs between 0 and 5, but we don't actually know where. So we want to use this by calculus. I think on your test, I wrote solve this by calculus. And so what is happening to the slopes of those tangent lines or the derivatives at those points? They're flatlined, they're 0. So we know that f prime is equal to 0 at the maximums. So what do we need? If I only have f of x, what am I missing? Yeah, we need the derivative. If we want to use calculus, we definitely need the derivative because we know the derivative is 0. So first, find f prime. So f prime of x is equal to 3x squared minus 6x. Is everyone okay with that? Okay. I took some leaps there, and I know this is a summer course, so if I was in your guys' shoes, I'm like, where'd you find that derivative from? Okay, so we have our derivative. We know that it's going to hit those curves either when the derivative is 0 or undefined. In this case, 0. So step 2, we are going to set the derivative equal to 0. So we have 0 is equal to 3x squared minus 6x. And we want to solve this for x. So notice that my first term and my second term both have a 3x in it. I'm going to factor out a 3x. So I get 0 equals 3x, and that gives me x minus 2. We can separate these. And so I get 3x equals 0 and x minus 2 equals 0. So x equals 0 and x equals 2. Now, if I didn't give you a graph, you wouldn't know which one was a max or which one was a min. You just know, okay, we have these points, and we don't really know what they're doing. So what we're going to do is make kind of a little Etch-a-Sketch graph down here. And we have x equals 0 and x equals 2. We know at x equals 0, f prime is 0. So they're flatline. This is the only places where my graph can go from increasing and change to decreasing, or decreasing and change to increasing. These are the only places they can really turn around. These are the only places f prime is 0. It's the only place that slope flatlines. So what we might want to do is find out what the graph is doing over here, what the graph is doing. I'm going to do this in a different color. What the graph is doing over here, what the graph is doing in between here, and what the graph is doing over here. So what is a nice number smaller than 0? -1. So I'm going to look at x equals -1, and I'm going to plug it into my derivative. So I'm going to look f prime at -1. So that gives me 3 times -1 squared minus 6 times -1. When I do that and I plug that in, I get 9. So my slope at -1 is 9. I don't really care about the number itself. I just care what's happening to the left of 0. And it's a positive number, which means I have a positive slope. So positive number gives me a positive slope. So that what that's telling me is everything from the left of 0 is increasing.
If we're trying to work on example, we just write the plus minus on it above it.
Yeah. As long as it's readable. And then we need to check what is it doing between 0 and 2. So what is a nice number between 0 and 2? 1. So x equals 1 is another test point. So we're going to look at f prime at 1. And when we plug f prime at 1 in, we get -3. So f prime at 1 is negative, and so f is decreasing. So it is decreasing everywhere from 0 to 2. And so what that tells me is at 0, my graph went from increasing to decreasing. So we had a little maximum here. This is step 3, by the way. The last thing we need to check is what is happening on the right side of 2. So it's zeroing out at 2, and then after 2, it's always going to do the same exact thing. So I'm going to look at x equals 3. So f prime at 3 is equal to 9. So f prime is positive. So that means f is increasing, our original function. So it's increasing. So at 2, we went from decreasing to increasing. So we had a min. Questions? Some of you are looking at this like it's going to eat you.
So for this one, did you not, points?
Yes, that's the last step we're going to do. So step number 4, find the points. So we had x equals 0. And so we're going to plug that 0 back into the original function. And when we do, we get y equals 9. And that's a relative max. And then at x equals 2, if you plug 2 back into the original equation, we get 5, and that's a relative min. And this would be your final answer. I'm realizing I did not give you guys enough space on the test to do this problem. I gave you a quarter of a page. So I'll just space it out differently. Okay, so any questions? You do have a problem like this on the test tomorrow. It is very, 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 very similar to this problem. I like this problem. This problem is a great problem. This problem makes me happy. Maybe shift it a little bit.
So like 2 to the left or 2 to the right?
It looks very similar. Okay. Example 4. Do you guys want to try this one?
Sure.
Okay, so go ahead and try this one, and then we'll do it together. About 2 more minutes and then we'll go through it together. All right. I know some of you aren't done, but let's go through this together. All right, first, find the derivative. So notice that this is a function inside of a function. We have to use a chain rule. Derivative of the outside, inside bit stays the same, times the derivative of the inside. So we have y equals x cubed minus 8 to the 2/3. That 2/3 drops down. So y prime, we get 2/3, 8 cubed minus 8, the inside stays the same, and then we have to subtract 1 off of it. So 2/3 minus 1 is negative 1/3. Be careful with that. But that's the derivative of the outside. We then need to chain or multiply the derivative of the inside, which is 3x squared. So simplifying our derivative just a little bit, you guys don't have to, is 2x squared over x cubed minus 8 to the 1/3. Questions on how I took those leaps? Okay. My DiffyQ students would be crying at that. They're like, what'd you do? Don't do it again. So if you guys have questions, feel free to ask. I tease them because sometimes they're like, what is 2 plus 2? Like, use your calculator. And then I've had them for 2 years now, so I can be mean to them. So first, find your derivative. Second, we know it's where G prime is 0 or G prime is undefined. In our last problem, our derivative wasn't undefined anywhere, so we didn't have to worry about that undefined. So first, I'm going to set it equal to 0. So I get 0 equals 2x squared over x cubed minus 8 to the 1/3. Well, we're solving for x. I'm going to multiply both sides by x cubed minus 8. X cubed minus 8 to the 1/3. X cubed minus 8 to the 1/3. That cancels. And 0 times anything is just 0. So 0 equals 2x squared. So then I'm still trying to isolate x. I'm going to divide both sides by 2. And I get 0 equals x squared. Still trying to isolate the x, so I'm going to square root both sides. I get x equals 0. So G prime is 0 at x equals 0. Now we need to know where it's undefined. If you have a function with a square root in it or a fraction in it, if it's a fraction, it's where the bottom equals 0. If there is a square root, it is where the square root piece is negative. With derivatives, you really have to worry about fractions. So what we're going to do is take G prime, which is 2x squared over x cubed minus 8 to the 1/3. And that's our y prime. And that is undefined. When x cubed minus 8 to the 1/3 is 0. So it's when I'd be dividing by 0. So I'm going to solve for x. I'm going to cube both sides. And I get x cubed minus 8 equals 0. Subtract or add 8 to both sides. And I get x cubed equals 8. And now I'm going to cube root both sides. And we get x is equal to 2. So we have our 2 points. Now we need to put them on a number line. So we have 0. We have 2. And now I need to test, are they maximum minimums or just neither? Are these critical points? What are they? So I need to test a point smaller than 0. So I'm going to test at -1. And so f prime at -1 is equal to a negative number. So if you plug -1 into our derivative, you get a negative number. So this is decreasing. Now we need to choose a number between 0 and 2. I'm going to choose x equal 1. So f prime evaluated at 1. If you plug 1 in there, you get a negative number again. So 0 is neither a max or a min. So it was decreasing, it flatlined, and then it decreased again. And we can see that in the graph. So it's decreasing, it flatlines here, and then it starts decreasing again. So occasionally that happens. Our critical point turns out to be neither. And then we need to test a number bigger than 2. So I'm going to test 3. is equal to 3. So f prime at 3. And we get a positive number. So my graph is increasing here. So from 0 to 2, it decreased, and then 2 to infinity, it increases. So it creates a minimum. And this was step 3. I keep forgetting to label that. And then step 4, we want the points. So the only point we care about is 2. So when x is equal to 2, plug 2 back into your original equation. We get y is equal to 0. And that is a relative min. All right, guys, any questions?
With the one on the test, like this one.
It's more like the one before.